Hello everybody. So I was thinking that you guys have maybe some interest to do this cell, to experiment with this cell. Uh, so this battery is some rechargeable zinc based battery. In my previous video I make this zinc hexacyanoferrite battery with higher voltage. The voltage was 2.3 volts. The normal voltage of zinc hexacyanoferrite battery is 1.8, but I create some 2.3 volts battery with some double electrolyte type. When I make this high voltage zinc hexacyanoferrite battery, I say that on the negative electrode I use some electrolyte which is made from potassium hydroxide with combination of zinc oxide, and the same electrolyte I use in this cell. So this cell produces about 1.5 volts and have the electrolyte which is made from potassium hydroxide and some zinc oxide. So zinc oxide is some storage of zinc ions. When you recharge this battery, the zinc ions will go to the negative electrode, and yeah, you will get some electroplating of zinc. That's why you can use current collectors on the negative electrode, which are, for example, some copper, carbon or zinc. So the zinc is the best negative electrode because you will get really good power, and also the capacity will be greater. To make the positive electrode, I use some manganese dioxide with combination of carbon black for the conductive additive. I use the active material from alkaline batteries, but if you want you can also make by your own. So the manganese dioxide which I use in this one is not the best. The best manganese dioxide will be some alpha manganese dioxide, but this one works also really good, but not the best. So I was thinking, if you have some interest to experiment with this type of cell, so I will show to you how to make and yeah, experiment with this cell. I will also put link in description for my previous video which I make zinc hexacyanoferrite battery with higher voltage. So here I'm making this positive electrode, which is in basic some graphite plate, and the active material is of course manganese dioxide and carbon black. But this active material I get from double A battery, alkaline battery. So in alkaline battery you have already some potassium hydroxide electrolyte, so it's no need for washing the material and so on. To hold everything together, this active material, I use of course this carbon fiber. And yeah, right now the positive electrode is ready. What I need to do now is I need to cover the entire electrode, because I don't want that the cathode will get to the anode. That's why I will roll into tissue paper. I need some tape to tape it together. So if you want, you can make some own active material. In this case, you need some manganese dioxide and some conductive material. The conductive material can be I don't know, some graphite or carbon black, or you can use the active material like I use from AA battery, alkaline battery. Need to be alkaline battery because in alkaline battery is the same electrolyte which you will use in this battery. It's a little bit hard with the gloves, but okay. Okay, cool. So right now I have the cathodes ready. Now I need to make the electrolyte for this battery. I need to clean my teaspoon. And now, yeah, the electrolyte. What a messy table, but okay. You need potassium hydroxide. So I will add, I don't know, 2 teaspoons into 35 milliliters of water. Okay, that's it. So the reaction water with potassium hydroxide is exothermic, so the reaction, I mean the water, will be hot. Okay, great. So here I have 35 milliliters of water and 2 teaspoons of potassium hydroxide. And now I need a little bit of zinc oxide. A little bit more. So the zinc oxide in this electrolyte is the source of zinc ions. So when you recharge this battery, the zinc ions from the electrolyte will go to the negative electrode and the zinc will be electroplated. So in this case you can use for the negative current collector you can use whatever you want. The best material for the negative anode is of course zinc, but if you want you can also use some copper, because when you recharge the battery the zinc will form on the copper. Also you can use some carbon if you want, but like I said, the best material for this job is of course the zinc. So right now we have the cathode, we have the electrolyte. Yeah, we need also some zinc metal piece. Also I will cut some piece of copper. Now we have the negative electrode, the positive electrode, and the electrolyte. And now I can change the table. Okay, first I will try, this is the positive. First I will try with copper, that you can see the electroplating of the negative current collector. Okay, I need to turn on the power supply, and the voltage I have set to 1.8 volts and 300 milliamps. And let's go. So after 1 minute we already get some zinc on this copper. And yeah, I mean, this rechargeable zinc battery is really simple to make. Okay, that's it. And you see really nice coating of zinc. .6. And also what is really good for this battery, that if the anode is made from different material, and if you not use some zinc electrode, you can discharge this battery to 0 volts, because the 0 volts you will hit when no zinc will be on this copper. But you will get some problems if you use some zinc electrode, because actually you can discharge the zinc battery so long that you will dissolve the entire zinc, but you will not get problems if you use some copper for the current collector, or some carbon for current collector. But with a zinc electrode you will get better performance. What I mean by this, you will get better power output, and also you will get more capacity. if you use zinc electrode. The voltage is the same. .6. Right now the curve is really good looking battery curve. Now right now you see a really nice looking curve. I mean battery curve. It's not like a capacitor curve like so, but it's really good curve. Here I have some big fall of voltage. This is because I make some penetration on separator which covers the cathode, and you also see the electrolyte is a little bit darker. So here I have some failures. Also my body is back. Hello. So I will stop here and I will repair the separator around the cathode, and then I will repeat the discharging process. So guys, this was this better runtime. As you can see, the curve is really nice looking battery curve, but here at this point my cable disconnected, and right now I get 57 minutes of runtime. So the energy density is around 34 watt hours, and yeah, you see this runtime is much better, like the curve, I mean the runtime before. So you can also see the problem was that I need to connect some copper on the top of this graphite for better connection. Without copper you get some bad connection, and you see the curve was also really bad. But now I connect some copper piece on the top to make better connection, and you see this curve. So guys, that's it all. I hope that this video was interesting. Like I said, experiment with this cell, and yeah. So guys, we see us in the next video, and bye.